All right, Math 2 students, let's get started on our Unit 4 review. There's a lot of stuff that we've covered here, so I'm going to try and give you some reminders. But it's also important that you use this as really a check against your own work. So I encourage you to make sure you go through, you're checking all your homework to make sure that you've done all those, that you've corrected all of them, that you've worked through the Khan Academy stuff. You've really got to learn this stuff before you do the review, because the review is just as a sort of final check. And this video is meant as a check against you doing the review. The best use of this video is going to be for you to check your work after you've already done it, or play it just to the point where you've got the hint that you need. But use the pause button a lot. That's going to be the best way for you to learn. All right. This draws on some of the stuff we learned last unit. So that means what does it mean for something to be an intercept form and to identify the intercepts? That in order to put something like this in an intercept form, what we need to do is find the factor it, find the factored form. So we're looking for something that will tell us what the intercepts are. That's intercept form. So we need to factor this. X squared minus 6x plus 5. A equals 1, B equals negative 6, C equals 5. Our product is 1 times 5. Our sum is negative 6. Since our sum is negative, that tells us that our product is going to be the result of two negative numbers. Right? Product is positive. It means that either it's a positive and a positive, or a negative and a negative. So in our box, we know we're going to be looking at negative and negative. And our first term is going to be x squared, and our last term is going to be 5. So we're looking for factors of 5 that add up to 6. It's really only 1 and 5. So we have 5 and 1. And these are going to be the coefficients on our x terms. So if you remember from Khan Academy, that was their method. They call it factoring by grouping. We call it the unbox method. They're both the same way of accomplishing the same thing. So we can factor out a negative 5 here, and we can factor out an x here. And then going this way, we can see that there's an x to factor out of both of these. And in this one, no number bigger than 1. But because this one's negative, we're going to factor out a negative 1. If you do this backwards now, you can see that negative 1 times negative 5 is going to give us the positive 5. So that means that our factored form is x minus 1, x minus 5. So the intercepts, right, that means when y is equal to 0. So we're saying, when does x minus 1 times x minus 5, when is that equal to 0? Well, that's equal to 0. So when y is equal to 0, when x minus 5 is equal to 0, in which case we're going to multiply stuff together and get 0, or when x minus 1 is equal to 0. This is our 0 product property. So x either equals 1 minus 1 is 0, or x equals 5. So that means we've got intercepts of 1 and 5. Now, if you're very familiar with a parabola shape, you'll say, okay, these are each 2 apart. That must mean that this is my midpoint line, which means my vertex is somewhere along here. That must mean that I traveled 2 over, which means I traveled 4 up. So you could say, look, this must be over 2 up 4, because a is equal to 1. That's what a parabola would look like. If that sort of feeling it out or familiarity with a shape of a parabola isn't where you are yet, there is a formula. From standard form, we said that the vertex can be found by finding negative b over 2a. Right? This is going to be the x value of the vertex. So this is going to be negative 6 over 2 times 1. So that means this is 3. So my x value of my vertex is 1, 2, 3, sure enough. So what's my y value? This is x. So now we plug that back into the formula. or to the function. You can either plug it in here, or you can plug it in here, because they're the same function. They're just, this is factored, this is standard form. I'm going to show you with factored form because we don't have to worry about the squaring and the multiplying. It's quite simple, actually, if we can do the process. Putting a 3 in, it's 3 minus 1, y equals x minus 1, times x minus 5, 3 minus 5. Now, when I say simple, I just, so you don't get discouraged or intimidated, simple doesn't mean easy. It just means not complicated steps. So lots of steps to do this maybe, but this particular step is just put the x value in, figure out what y is. 3 minus 1 is 2. 3 minus 5 is negative 2. That means x equals negative 4. So that's how I know that my vertex is at 3, negative 4. From there, draw a parabola. So parabola, remember, it's over 1, up 1, over 2, up 4, it'll over 3, up 9, so it's going to be increasing in its steepness. All right, number 2 and number 3 are what they sometimes call special cases. And in both cases, I want you to notice about the first and last terms. First and last terms. This one only has a first and last, but 25, 49, 100, and 81. What do they all have in common? They're all perfect squares. So this we would call, sometimes it's called dots, difference of the squares. Okay, difference of the squares. So we have 10 times 10 and 9 times 9. This one we have 5 times 5 and 7 times 7. So in both cases, if we were to put this into a box, right, we're looking at factoring these as perfect squares. Now the reason I know that we're going to do that they will factor exactly into 10 and 10 and not 101 or not 25 and 1 is because, or 25 and 4, lots of different combinations of 10, is because they're both perfect squares. What happens here, right, is that these two will cancel. So one of them is going to be positive and one of them is going to be negative. These ones, they're both going to be the same side. They're both going to be negative. So they're not going to cancel out, they're going to double. Right? So I'm going to say that, look, if these are both perfect squares, then that means that they're the result of the same number multiplying them. Yeah? So that means that we're going to have a 5 times 7 here and a 5 times 7 here. Same with this. This is 9 and 9. But instead of it being the same number and the same sign, they're going to be opposite signs. Right? So this is going to be a plus 90 and a minus 90. Oh, Z. Excuse me. Z. This one, the other, is going to be the same sign. Negative 35n and negative 35n. So again, what I'm recognizing is that they're both have beginning and ending of perfect squares. And that must mean that in this case, these two terms are twice the 5 times the 7. So square root of 25 is 5, square root of 49 is 7. And so this is 2 times 5 times 7. And because this is negative, I know that they must be negative numbers. So I must have a negative here. This one, I know that the last one is a negative number, so it must be a positive 9 and a negative 9 to give us a negative 81. And because one's positive and one's negative, when you put it into the when you put something like this into the box, those middle terms cancel out. Okay, so this becomes 10z plus 9, 10z minus 9. That's the difference of squares. This is 5n minus 7 squared. Perfect square trinomial, difference of square. Okay, those are the special cases. Now we're going to solve these quadratic equations. It says solve the following quadratic equation. A couple different ways we could do this. You can always do completing the square and taking the square root of both sides. You can also use the quadratic formula. But this one actually lends itself to factoring. If you're not sure, you can always try one, see if it works. But I'm going to show you how this works. Whenever we're solving a quadratic equation, we need to start with, if we're factoring or using the quadratic formula, we need to start with making sure everything is equal to 0. So 5x squared plus 13x minus 18 equals 0. Right? Then we can have a equals 5, b equals 13, c equals negative 18. So 5 times 18 is 90, so our product is 90, and our sum is 13. Now, I wrote and said 90, but notice this is negative 18, so this is going to be negative 90. So that means I've got to find a product of 90 where one of them is positive, one of them is negative, which means I'm doing some sort of subtraction. So I'm trying to find products of 19 where the difference of them is 13. All right, so here we go. Products of 90. 1 and 90. 2 and 45. Well, the difference of that is 89. Nope. The difference of that is 43. 3 and 30. Difference is 27. 4, no, not 4. 5. 90 divided by 5. 18. 5 and 18. Oh, hey, 5 and 18. Okay, so first term goes in here, 5x squared. Last term goes in here. Then I notice this one is a positive 13. That must mean that I've got a plus 18x and a minus 5x. Some of you miss this step and you go right to the factored form. And you put the 18 and the 5 in, but that's not what we don't do that yet. What we do is we factor and we say, okay, this is going to be 18. This is going to be x. Actually, not just x, but 5x. This one's going to be minus 1. There's nothing else that factors out except a negative 1, and this is going to be an x. So I have x minus 1 and 5x plus 18. So we factored, now we need to solve. So either x minus 1 equals 0 or 5x plus 18 equals 0. So either x equals 1 or solve x equals negative 18 over 5. If you like decimals, you are welcome to put that in and say negative 3.6, but that's not necessary. All right, number 5, put in vertex form. Okay, this is one of the main reasons why we learn completing the square, so we can take something in standard form, put it in vertex form. So this is completing the square problem. That's how we can do this. Y equals x squared minus 14x. Perfect square trinomials always have a plus, so we're going to say, well, this is plus something minus 32. Okay, so I just copied this same thing down, and I said, okay, what is this going to have to be in order for this to be a perfect square? And if I have to add something, then in order for me to keep this function exactly the same value, I have to subtract it again. Right? So I could say, well, plus 1 minus 1, plus 2 minus 2. Those would cancel each other out, and I wouldn't have changed the value of this. the question is, what do I have to add here so that I can create my own little perfect square trinomial? B squared over 4a is our formula for getting what this is. So that's going to be 14 squared, 196 over 4 will give us 49. So this is plus 49 minus 49. So these cancel each other out. Now, I'm not going to cancel them out right now. That just gets me back to where I started. But the point is that I haven't actually changed the value of this. I've just put a plus 49 and a minus 49 in. What that allows me to do is to take this then and factor it. So that becomes y equals what squared? Well, if you're looking at the perfect square trinomial, you can say, oh, it's this same situation where I've got perfect square here, perfect square here. So this is x. Negative in here means it's a minus, and the square root of this is 7. And then I've got all this stuff here left over, right? So this is minus 49 minus 32. So what's my vertex? Well, vertex form, remember, is y equals a times x minus h squared plus k. So that means h is 7, right? It's the number that comes after the minus sign, or the opposite of what it is. So it's not negative 7, it's positive 7. And then my vertex is negative 81. All right, going on to the second page. Solve the following quadratic equation. Well, if you're looking at how this is set up, you can see that I've already got something factored as a square, a perfect square binomial, right? So that means I'm really set up well to use the square root method. All I have to do is get the squared thing by itself. So this is how we do that. We divide the whole thing by 5. 5 divided by 5 is 1. And I've got 2x plus 3 squared equals 55 divided by 5 is 11. Then I take the square root of both sides. So that means that when I take the square root of something that's squared, it's 2x plus 3 equals, and remember, we have take a square root. That means it can either be the positive or the negative. So I'm going to actually start calculating this, and on your test I'm going to say round to 2 decimal places, or I believe I said this. I say this at the top of this. Yes, round all answers with square roots to 2 decimal places. So I'm going to take the square root of this. It's about 3.32, right? 3.316, so the 6 rounds up to the number before that. So this is either positive or negative 3.32. So that means that 2x either equals (3.32 minus 3) or 2x equals negative 3.32 minus 3. So either 2x equals 0.32 or 2x equals negative 6.32. So dividing this by 2 is x equals negative 3.16, or dividing this by 2, x equals 0.16. Now, last one. Solve the following quadratic equation. We could try and factor this. Okay? But to do that, we have to get everything over to one side. So let's say minus 18 and minus 4. And we have 6x squared minus 21x minus 23 equals 0. Boy, this does not look promising to me. If I were going to factor this, I'm going to be looking for 6 times 23. 6 times 23 is 138. 23 is a prime number, so that means there aren't that many factors. And I'm going to be looking for something where the difference in those factors is going to be 21. So this is a candidate here for the quadratic formula, the last thing we're learning this unit. I could try and factor that, but this is not, it's going to be really a lot of mental work and guesswork, and I might end up not finding anything to factor. So good technique here would be to let's go to the quadratic formula. A equals 6, B equals negative 21, and C equals negative 23. So quadratic formula says if we have a trinomial, x squared, x number, we identify A, B, and C, that means that our solution is going to be negative b plus or minus, that plus or minus, remember, is when we take a square root. Square root of b squared minus 4ac, the whole thing divided by 2a. So let's do that. X equals negative b plus or minus the square root of b squared minus 4 times a times c. It's a negative. It's important you keep those negatives there where they are. So that's why whenever I have a variable from here, I put the parentheses and then I double check to make sure I'm putting the signs in correctly. Then 2 times 6. Okay? So this is negative 21 plus or minus the square root of 21 squared, 441. So then I've got 4 times 6 times 23, 552. So this is going to be minus, so this is plus 552 plus 441 equals 993 over 12. So this is 21 plus or minus the square root of 993 over 12. So the square root of 993 is about 31.51. So this is either 21 plus 31.51 over 12 or 21 minus 31.51 over 12. Remember how parabolas here, we can see one here, they dip and then they come back up. So that means that any value of y, you're going to have 2 values of x if you're here on the parabola. So that's why we have 2 answers. Just a matter of calculating these. Plus 21 divided by 12. So either x is 4.38 or 21 minus 31.51 divided by 12 equals negative 0.875. So this is a negative 0.88. Okay. And, quite frankly, the quadratic formulas and problems that you find in real world, in physics and engineering and statistics and biology, when you talk about bacterial growth, they don't come out in nice round numbers. They come out in decimals like this. And that's why we need to be able to work comfortably with decimals, not freak out when we see them. So this is how this one works out. Quadratic formula, square root. Now we're on to just a comprehension of systems of equations. So this means that we've got an equation. This equation I can see here. I'm not going to require this you to be able to do this, but this is y equals x minus 1, and this one is y equals looks like 1/2, because it's x, let's see, minus 1 squared minus 4. So this is vertex form. I can see that my a is going to be 1/2. I'm just showing you this because what I'm saying is these are two equations, and I'm trying to say what value of x and y is going to work in both of these. And that's why graphing them can help us. There's one. So this is the solution 5, 4. And there's one. That's the other place that also works. So this is the point -1, -2. And if you plug them in, you can see that 5 minus 1 is 4, and -1 minus 1 is -2. Similarly, if you plug this in, you can see that, well, if x is 5, and 5 minus 1 is 4, so that's 16. Half of 16 is 8. 8 minus 4 is 4. So you put 5 in, you get 4 out. Or if you do -1, you can say -1 minus 1 is -2. Squared is 4. So half of that is 2. 2 minus 4 is -2. So I put -1 in, I get -2 out. So both of these points work in both equations. All I'm asking you to do is be able to look at a graph and say, I can see what I mean when I say a solution to a system is the places where these functions intersect. Now we have a application problem.